Hey, AP Stats, Mr. Ellinger here, and we're continuing the notes that we started on Friday. So, so just to remind you what we were talking about when we were doing this, we were talking about how in the last chapter we'd kind of have this godlike knowledge, like we'd know what the real mean was, or we'd know what the true proportion is of something that we're curious about. And if you think about it, like if you knew what the real percentage is of signatures that are legit, then why are we sampling? Like, why do you bother if you already know about every single signature? Or the same thing here. If you already knew that 45% of high school seniors felt prepared for college in this state, why would you take a sample? You already know the answer for everybody, so what's the point of taking a sample? The reason why we had that last chapter is it sets up our math for this chapter, where we say, okay, pretend you didn't know what the true number was. How could you go from a sample and say anything? How would you know anything about what the true number was if you just started with a sample? So that's the mission we had. We talked about it for a bit in class, and I'm a little frozen. There we go. Yay. And we ended with Wyatt and I up in the front. We were talking about how if you are the true proportion and you spread your arm out 2 standard deviations, then 95% of the samples, my arms are out really wide, but I'm close to the screen, 95% of the samples are going to be between my arms. And now we're going backwards because we're just flipping the perspective. Suppose I'm one of the little pea hats. I'm a little pea hat. And suppose I spread my arms out the same distance that Wyatt did. Then if I spread my arms out, I'm a little pea hat. The hat's up on the bookshelf. I'm a little pea hat. If I spread my arms out wide, the same width, then if I'm one of those 95% of, we'll call them ordinary samples, then I'll be able to reach Wyatt. Now, if I'm one of the weird samples that are way far out there on either side of it, then I won't be able to reach Wyatt. So just like we talked before, that you'll have a 95% of samples that are kind of in the middle, and then there'll be occasionally you'll get a weird sample on the outside. So if you're one of the ordinary samples, then this system is going to allow us to give an interval that contains the true proportion. Let me show you what I mean. So there's some normal curve. That was a really bad normal curve, but I'm on the clock. And we don't know what it is. But we know that 95% of the samples are within 2 standard deviations of it. Remember, this is talking about sampling distribution. So these are a collection of all the possible p hats that you could get given whatever that proportion is and whatever your sample size is. And there'd be lots of p hats right in the middle, right? Because that'd be really common that you get right at the true proportion. So now if I'm one of those ordinary samples, if I spread my arms out, change color here. If I spread, suppose I'm this p hat right here. If I spread my arms the same distance that Wyatt was spreading his arms, then my interval will contain Wyatt. And as long as I'm any of the p hats that are in the ordinary 95%, and I spread my arms out as far as Wyatt spread his arms out, then Wyatt will be in my range. The only thing is, every once in a while, I might be a weird sample. I might be a p hat, just a bizarre sample. You don't know it, but because you just get the numbers, but you just get a bizarre sample sometime where, wow, it's just, you flip a coin and it just comes up heads a lot. And then if you spread your arms as wide as Wyatt does, if you're this p hat, then you're not going to contain the true p. So 95% of the time, 95% of the samples, maybe I should say, 95% of the samples will create intervals and the true p will be inside. And all of them are correct. If they say, I think the real number is somewhere between here and here, between here and here, then they'll be correct. But one of the weird samples way on the side, if they do the same thing, they're not going to contain the true proportion. So this is a system that's not going to always work, which is kind of bizarre. But if you think about it, like, it's possible that you have a bizarre sample. It's possible that like a coin is perfectly ordinary and you flip it 100 times and you get 75 heads. It's possible. You could be a weird sample. And then you might think the coin was bad when really it was just a weird sample. Okay, let's go through this stuff right now. We're going to be a little more direct on this. So what is a confidence interval? A confidence interval is a range around your statistic and your some percent confident, the true number, which remember that's the parameter, right? That's the number for the population, is within your grasp. So a confidence interval is a range around your p-hat. In the case of proportions, it'll be x bar later on, the next chapter. So it'll be a range around your p-hat, and this will be your confidence interval. And you'll say, I'm pretty sure the real, as long as I'm a normal sample, then I think the true proportion is somewhere in this range. What is a confidence level? The confidence level is going to be that, how sure are you? Or what percent of samples is this going to work for? The confidence level is that's your 95% part of it. So 95% of the time, 95% of the samples, when they make an interval around them, it'll work. 5% are too extreme, and when they make an interval, it's not going to work. So this is not a foolproof method, but it's because of sampling variability. You never can be sure. You can flip a coin 100 times, and you can get 0 heads, even though it's a normal coin. Not likely to happen, but you could. And so we can't create a foolproof method. So a confidence level, that's the 95%. That's how confident your interval captures the true proportion. Or another way of saying it is, it's what percent of samples will create true intervals. So sometimes you'll get a weird sample and the interval is going to be wrong. But that's okay. You're not going to be wrong about what you say. We'll show you how it works. The margin of error is when we've got our p-hat, we're going to go a little to the left and we're going to go a little to the right. And it's going to be a number, don't worry. And that's the margin of error, is how far over do you go from the left and right of your p-hat. So like we've got 73% right now. Suppose the margin of error is 10%. Then we'll say, we think the real proportion is somewhere between 63% and 83%. We'll make a range around our sample result. So the margin of error would be 10%. This is 73. I'll draw this up. If my value, my p-hat is 73, and if my margin of error is 10%, I don't know what the margin of error is yet. And if the margin of error is 10%, then my interval is going to be between 63% and 83%. So I'll say, okay, I got 73%, but I don't know if that's exactly right. So I'm going to say I'm pretty confident that the real number, whatever the real number is somewhere between 63 and 83. My sample is 73, but who knows if that's exactly right. But the real number, whatever it is, I think it's between 63 and 83. That would be what would happen if you had a sample result of 73% and your margin of error was 10%. So one question is, which is better, a small or a large margin of error? And you might think, well, that's kind of dumb. It should be kind of obvious, isn't it? It's actually not. So think about this situation. Suppose you've got a weather person and they say it's going to rain somewhere between half an inch to an inch. So that's my margin of error. That's my interval. Okay, that's helpful. What if the weather person says it's going to rain exactly 3/4 of an inch tomorrow? Well, that's kind of nice because you're being very, very precise about it. They're being very, very exact. They're saying it's going to be this number, but at the same rate, they're probably going to be wrong. It gives you an idea of how much it's going to rain, but Is it going to rain exactly that much? They don't know that. And so if you're really, really precise, the only problem is you might be wrong in your result. You might not be accurate. You might not be true. And so a margin of error or an interval that's too small is kind of helpful, but it's also kind of not helpful because it's probably not going to be right. And then you say, well, yeah, but you wouldn't want to have a huge margin of error. Well, there's pluses and minuses. If you have a huge interval, then you're probably going to be right. I mean, if I say it's going to rain somewhere between 0 inches and 2 inches tomorrow, well, okay, you're probably going to be right about that. So it's nice because it's wide, and so from that standpoint, you're probably going to be right about it. But at the same rate, if I say it's going to rain somewhere between 0 and 2 inches, that doesn't really help you know like how to dress. Or if I say the weather tomorrow is going to be somewhere between 30 degrees and 100 degrees. Okay, big interval, but not very helpful in a way. So that's the trade-off. So you can write this however you want to, but there's a plus and minus in having a confidence interval that's too wide or too narrow, and we'll talk about how you decide how wide to make a confidence interval. But how we can reduce the margin of error if you want to have a narrower margin of error. One thing is you can lower the confidence level. You can say, I don't need it to work for 95% of the samples. I'm okay if it only works for 90% of the samples. So that's one thing you can do is you can say, well, I'm going to be a little less confident about it. And so I'm going to have a narrower interval. It's more precise because it's giving you a narrower range, and so it gives you a better idea of what the real number is, but it's opening yourself up to being wrong. That's one way you can do it, is by lowering the confidence level that shrinks the interval because you're trying to be more exact, but your chance of being right has gone down. The second thing you can do is you can increase the sample size. As we saw in the last chapter, the bigger the sample size, then the tighter the sampling distribution. Think about the Penny Project. You do a sample size of 5. It's pretty. It definitely narrowed it from the original population, but not that much. You do a sample size of 25, then it got really, really small, and then it was very, very precise. So that's one thing that margin of error is totally reduced if you increase the sample size, because then there's less variability in the samples. Okay, so now we're going to go through the procedures for doing a confidence interval. And I'm going to take a break in here, and you're going to watch another video. So you're going to read the problem and state the procedure you'll try. And in a moment, you're going to watch a video where they're going to explain this. And how do you decide what procedure? You can ask, well, is it looking for a confidence interval? Like, does it say it in the problem? And you're going to see the video, Josh Tabor's video, where you'll see an example of that. And are we talking about means or proportions? Just like in the last chapter, is it quantitative data or qualitative? Is it asking for a percent or is it asking for the mean value? Right? Those are the two kinds that we're going to be able to handle in the beginning. And then is it based on samples from 2 populations or just 1? On the test, you had a problem that involved homes from 2 different places, or incomes from 2 different places. That was a 2-sample situation. Or you might have a problem that just involves a sample from one population. So you're going to look at all those things. Do I have enough time for one thing? I do. And the other thing you're going to do is you're going to define your parameters. So in the problem we're going to have, we have the value P. And you want to actually write this down. What does P stand for in this problem? And P stands for the true proportion of the signatures that are legit. Remember that some of them might be from out of the region people, some of them might be, a weird signature where it can't be validated what the person's right, and they have to check what percent of the signatures are good signatures. And so when we write the letter P now, we're saying that stands for the true proportion, and true is kind of redundant there, but I'm just trying to be really clear about it. It's a real number for the whole population on how many signatures are legit, what proportion overall. Okay, I'm going to be out of time. You're now going to watch the Josh Tabor video, and he's going to explain a lot of stuff for the next part. Good luck.